Good morning, grade 10. I hope you have a splendid day. We are busy with trigonometry and it is the 25th of May. We're looking today at special angles, and by now you have copied the following notes. It says that for the most angles we need a calculator to calculate the values of sin, cos and tan. However, there are some angles that we can easily work out the values for without a calculator, as they produce simple ratios. The values of the trigonometry ratios for these special angles, and we call them special angles, as well as the triangles from which they derived, are shown below. Quite important, you should note that remember that the lengths of the sides of a right angle triangle must obey the theorem of Pythagoras, and the square. So what does Pythagoras say? What does Pythagoras mean? Pythagoras says, the theorem of Pythagoras is basically, what does this mean? The theorem of Pythagoras, it means that the hypotenuse squared is equal to the two other sides. Alright, so let's call this, we don't have angle names here, so I'm just gonna use the numeric values, which is square root of 3 and then plus square 1 squared. Alright, so that's what it means. That's the Pythagorean theorem. And what we need to, if we do this, we need to state that this is Pythagoras. Alright, so why is this important? Because sometimes you will not always be given the third side. Sometimes you will be given two sides, that's known, and then you need to determine the third side, and we need that we make use of the theorem of Pythagoras to prove the third side. So this you have copied now. If we check, so we know this value, but if the value was given to me like x and I was supposed to determine that value, I would have said this is the hypotenuse. And how do I know it's the hypotenuse? I know it's the hypotenuse because it's opposite the right angle. Alright, and now I say that means x squared is equal to, what is the square root of 3 times with the square root of 3. If I go to my calculator and I check that, I know I'm just checking for security. I know what the answer is, but I'm just trying to show you. So square root of 3, what does the square mean? The square means I need to multiply the thing with itself. So I can type it like this, no? And then my answer is going to be 3. Or if I typed it in another way, if I type bracket, where's my bracket sign now? Bracket, square root of 3 and close bracket, sorry, the square, then I close the bracket and I square the whole bracket, then my answer is always going to be the same. Alright, so if we have a square root and we square the square root, the answer is going to be the base. Alright, so that becomes 3. What is 1 square root? Square root of 1 is 1, because that's 1 times 1. So that's going to be 1. So this means x squared is equal to 4. But do we want x squared or do we want x? We want x. So how do I get rid of the square root here? I say x squared is equal to square root, not square root. I say this is 4, but I want to get rid of the square root right there, the square, so I square on both sides like that. Alright? And then this, my answer becomes x is equal to plus minus 2. But because what is x? X is the distance from one point to another. It can only be a positive value. So therefore, it's not going to be a negative value. But just keep that in mind, because further on future references, you might use it like that. Alright. So that's that. We're going to look at further more special angles, more special triangles. Once again, it's the repeating of the same. So let's quickly solve this one. It's the same actually as what I did just now. No? But we know this side is ultimately, by theorem of Pythagoras, I can go prove that this side is equal to 2. No? And then I have, this is what we call the 60-30 triangle. And we can, and this is, alright, so here my hypotenuse is not given to me. And how do I determine, by using the theorem of Pythagoras, how do I determine this side right here? I want to determine what is the length of this side. Alright, so I'm going to use the theorem of Pythagoras. I'm going to say I need to determine the hypotenuse. So I know that hypotenuse squared is equal to this side squared, alright, 1 squared plus 1 squared, alright. So that's 1 squared plus 1 squared. And why am I saying this? Because we need to state in geometry, all kinds of geometry, we always need to state our reasons. So we're going to say Pythagoras like that. And now I'm going to solve. So the hypotenuse squared is equal to 1 squared plus 1 squared. So that's 1 plus 1, which equals to 2. And then that means the hypotenuse squared is equal to 2. But I don't want the hypotenuse squared. I just want the h. Alright, so that becomes, let me just fix that. That becomes h is equal to plus minus of square root of 2. Alright, so, but we're working once again with a distance here. So that means this side right here is square root of 2. No? Square root of 2 is not equal to 1. Alright, so square root of 2, if we check on our calculator, square root of 2, square root of 2 is just remains square root of 2, or you can change it. But we're going to work with the square, with the third forms. Alright, so we're going to leave it as square root of 2 like that. So we leave it as that, and now, so that is the theorem of Pythagoras. And now they ask us, and I want you, so in this case we're looking at what we call, I almost don't want to use this name, but most likely it's referred to as the impossible triangles. Because why is this impossible triangles? Because what do I need for a triangle? I need 3 sides, alright, and 3 angles. That is why it's called a triangle. But let's not use this name. But this side, it has, that's 90, and that's 90, and this is 0 degrees. So basically, there is a side that has 0 distance here. And that's why we refer to that as the impossible triangle. So most likely, you will not be asked this, but I just want you to take note and you need to understand. So if I take, for example, let's use the ruler. All right, if I draw a 90 degree angle, all right, and I say that I draw another angle, but that angle is not going to be like 30 or 60 or 55, but that angle has to be 0 from there. It has to be exactly 0 degrees, all right, so it basically means it's a line drawn on that line. So the distance between the 2 lines is actually two lines next to each other. So that's how we got to that. But this is just this triangle thrown on the side. Do you understand? Let's look at it from this way. So this triangle actually looks like this. Oh no, that is the other one. All right. So that is this one here. This one here. But if I were to draw this one and I say I'm going to start in this corner right here. No? And I'm going to draw a line. And let's say that line is one distance, 1 unit long. And then I need to make, on that line, I need to start here. So I'm having a new point there. And I need to draw another, the third side is going to be, how much degrees is that? 0 degrees. So what am I drawing? I'm drawing from the same point and it's lying on the same point. So what is the distance of this side right here? The distance of this side right here is 0. Do you understand? Alright, so sometimes we refer to that as the impossible triangle, but it does exist. Alright, but it's actually the third side is no distance, and the other 2 sides is equal to 1. Alright, so that's that. Now, in essence, they ask us in the example, and we're going to do this example together, determine without the use of a calculator. Alright, so you need to know all of these triangles right here, and then you need to use these triangles to determine the following. So it's only going to be a 30. So if this side is 45 and there I have a 40, this is called an isosceles triangle, and then I have, this will also be 45. So I have a 30, 60, 90 triangle, then I have a 45 triangle, and then I have my 2 impossible triangles. Alright, so let's check. And I want you to write with me, determine the use, without the use of a calculator, all of these. I'm going to give you a minute or two to write this down, and then we're going to look at it together. There's 10 that we're going to look at now. Good. By now, I hope that everyone has gotten a chance to copy all of the problems that they are asked that we should solve, and also these 4 triangles. Okay. So determine without the use of a calculator, and this first one has already been done to us, but let me just explain and how do they get to the answer. If we go stand in this corner right here, all right, so we're looking from our reference point, and there we are standing, and we know that cos is what? Cos is? Cos of, but what is cos? What is the ratio of cos? Adjacent over hypotenuse. So what is my adjacent side? What is my adjacent side? Adjacent is square root of 3, and my hypotenuse is what? 2. Alright, so that one wasn't right. Let's check. So it should be square root of 3 over 2. Alright, so let's do that. Square root of 3 over 2. Thank you. Alright, so as I'm saying, you should just correct that first one. So if we say cos of 30, we're going to that, and we're standing there, that's my reference angle. What is cos? Cos is adjacent over hypotenuse. So we know if I want to go and I'm looking from that corner, that perspective, it should be square root. What is my adjacent side? Square root 3. And what is my hypotenuse? 2. Alright, now let's check. We're being a little bit sneaky here, and we're checking on our calculator. What is the cos of 30? Alright? It's going to give you that answer. So you see, you can always, although they ask you to do it without the calculator, you can always check. Alright? But let's go on. So that is what we are doing there. Let's do the rest. What is cos of 60? Now I'm not standing at the same angle, but I'm standing from that angle, and I'm looking from this reference point here. And I know that cos is adjacent, so let's quickly write it in. It's adjacent over hypotenuse. Alright, so that's cos. And what is my adjacent side there? If I'm standing from this angle, what is my adjacent side? My adjacent side is 1 over 2. Once again, we're being a little bit sneaky here. So we can check cos of what? Cos of 60. And I know if I work correctly, it's supposed to give me half. Alright. So let's leave the calculator for now. Let's check sin of 45. So which triangle am I going to use, Cole, if I want to work with? Sin 45. Is it the first triangle or the second triangle? The second triangle. So I'm going to stand here. This is my reference point. I can look either from that point or I can look from this point. Doesn't really matter because both angles are 45. And this is called an isosceles triangle. Alright. You're getting too clever. So, if I'm standing here and I'm looking, what should I determine? Sin of 45. So, what is sin's ratio? What is opposite over hypotenuse? Alright, so we go right, opposite over hypotenuse. And now I can see, but if I'm standing from here, what will be my opposite? 1. And my hypotenuse will be? Square root of 2. Alright. What is cos of 45? Cos is going to be, I'm using the same angle, so I'm going to say square root, cos is adjacent over hypotenuse. And then I'm going to say cool, so that means I'm going to look at it like, so I'm standing in the same triangle, same reference point, and I'm saying, what is the adjacent side there? It's 1 over square root 2. Now I'm working with tan of 45. So what is tan? Opposite over adjacent. Let's write in that a ratio that's opposite over adjacent. Alright, so if I'm standing in my in my 45-degree triangle and I'm saying opposite over adjacent. That's 1 over 1. And 1 over 1, we always try to simplify, is equal to 1. Let's check our calculator. If you don't believe me, let's check on our calculator. Calculator, let's see. That is, we go to our calculator, we type in tan, and what are we working with? Tan 45, we close the bracket like that, and then we get 1. Wow, amazing. You smarter than a calculator. Cos of 0. So I'm going here what I call, or what I refer to as my impossible triangle. All right. So I'm looking at my impossible triangle. I'm saying cos of 0. Cos is what? Adjacent over hypotenuse. So what is my adjacent side here? Adjacent side. So I'm looking from this perspective. I'm standing right there. I'm standing there, all right, because I'm saying cos of 0. So what is my adjacent side? My adjacent side is 0. What is my hypotenuse? My hypotenuse is 1. And that is 0 divided by 1 is equal to 0. It's 0. Let's check on our calculator. If you don't, 0 divide by 1 is equal to 0. Alright, let's check. Cos of 0. Alright, so let's check where we made our mistake here. Cos of 0. Let's quickly go back. Cos of 0. So cos is adjacent over hypotenuse. Alright, so this side doesn't have a hypotenuse, but the hypotenuse will be 0 over what? 1 over 1. Yeah. Alright, so it's 1 over 1, which equals to 1. Thank you there for the correction. Alright, sin of 0. Sin of 0, what is sin? Sin is once again opposite over hypotenuse. Opposite, so I'm standing there, I'm saying it's 0 over 1. 0 over 1, so it's going to be 0 over 1, and that is equal to 0. Tan of 0. Let's do tan of 0. Tan of 0 is opposite over adjacent. So I'm standing here, what is my opposite? 0 over 1. Alright, 0 over 1. And that is equal to 0. Now I'm doing cos of 90. What is cos of 90? Alright, let's go to our, we need to, because they said here determine without the use of a calculator. So you need to draw the triangles for me here. Alright, you don't have to draw a complete sketch, but you can just quickly make that. So if you know that's the 60, 90, and you need to study this, draw it over and over, that's the 90. Mine doesn't look right now. So let's quickly see if I can do some magic here. Let's see if this happens. Whoa, you see? And then we do that, we put in that. So I should know that the side here is always going to be square root 3. And this side is going to be how many degrees? That's 30 degrees. No? This is 90 degrees. I can see that. That is looks to be 60 degrees. That will be 1, and this will be square root of, not square root of 2, but 2. No? And then I should know my next triangle is my 45-degree triangle. So if I have a 45-degree triangle, I should know my right angle is there. This side and this side is equal. They are both equal to 1, and that is will equal to square root of 2. That's 45 degrees, and this is also 45 degrees. That's basically your two triangles that you need to know. All right. And then, if we're looking at cos of 90, all right. So cos of 90. Let's go to cos of 90. So I'm standing in that triangle right there, and I'm saying cos is adjacent over hypotenuse. So what is my adjacent side? My adjacent side will probably be 1, and the hypotenuse will be 1 over 1. Hypotenuse, adjacent over hypotenuse. Let's just check that. Cos of 90. It's going to be 0. So it should be 0. Adjacent side is this side that I'm looking at. Alright. So it's 0 over hypotenuse, which is 1. 0 over 1, and that equals to 0. Did you check the answer in the calculator? Alright, so cos of 90, that is equal to 0. Cool. And then the last one is sin of 90, and sin of 90 is, sin is opposite over hypotenuse, and that is equates to 1 over 1 is equals to 1. Alright, so that's what you should have done there. That's the expectation. You need to study these triangles and know how to apply them. They might not always give you the triangles. Then you should know how to draw it. Alright, so, but the moment when you see cos 30, cos 60, cos 45, when you see 30, 60, 45, and etc. like that, you can use this. All right. So class exercise that we're going to do now is going to be 5.3 and 5.4. What we don't finish in class is homework. All right. So I'm having this on proof now, and then afterwards, if there's time, we're going to look at the activity of the answers of 5.2. Stay here. I need to show you this. Alright, good, grade 10. So right now we're looking at the exercise, but I want to show you a quick cheat that I sometimes use, because they're most probably going to ask you in special triangles doing it without a calculator. So I tend to forget the triangles. Alright, so I forget how to draw them. But I know of a table that I can use, and my table is almost like the one that you copied, but a simplified one. Alright, so it looks something like this. I'm going to start and I'm going to write 30, 60, and 45. Alright, and then I'm going to write A, O, H. And then I'm going to do the following. And I want you to take special note of how I'm doing this. What does the A stand for? Adjacent. What does the O stand for? Opposite. And what does the H stand for? Hypotenuse. Alright, so what I'm going to do now, I'm going to fill in first of all my square roots. So this is square root of 3, this is square root of 3, and this right here, my hypotenuses will always be 2, 2, and this should be a square root of 2 as well. You see that pattern creating there? And so there's a pattern right there, that's square roots. This is all, let's use another color. This is all 2's that I have down there, but the last one is a square root, and then all that's left for me to fill in is 1, 1, and 1. Alright, so if you look at that, you can use this table. And this table is actually my cheat that I sometimes use. Now for this expression, I'm going to ignore these answers that they give me, and they ask me cos of 45. Alright, so I go cos, and I say cos of 45. So I will be working around here. What is cos? Cos is adjacent over hypotenuse. So I should know that is, if I go to my table, this is cos of 45 adjacent over hypotenuse. So then I would write 1 over square root of 2. Alright? And then I go to sin of 45. So what is sin? Sin is opposite over hypotenuse. So that's going to be sin of 45, I go to there, is also going to be 1 over square root of 2. Let's try tan of 30. Now, tan of 30, what is tan? Tan is opposite over adjacent. Alright, so I go to tan of 30, I'm standing in that line. I need to take the opposite, which is 1 over square root of 3. 1 over square root of 3. I would like you to complete. That is a cheat sheet that you can use. I will try to send this out on the group as well. Have a lovely day, grade 10.